Hey guys, David here and welcome to another endurance laser video. Today we're doing a comparison between the 10 watt plus and the 10 watt laser from them. Now, while the name suggests that these two lasers are very similar, apart from the diode being the same, they are actually quite different. Right here mounted on my laser here you can see the 10 watt plus model. It is quite a bit larger and it also packs quite the punch. And while the 10 watt laser is purely passively cooled, the 10 watt plus laser is fully actively cooled with two Peltier elements and a super powerful fan that removes all the heat, and that allows the laser to get super cold and be operated at quite high power levels that would just completely burn it up on the 10 watt laser. This, however, causes the laser to be quite a bit heavier, which just means that the accelerations on your machine can't be quite as high if it isn't built as sturdily. But it's not very heavy either, and it's still no problem for any 3D printer. There also is an air assist included that you can see mounted here on this machine, and it is just fed from an air pump, then with the stream of air coming out of a tiny nozzle here that you can position exactly over your cut. With the 10 watt laser this is not included and you will have to add it separately, as especially if you're cutting wood, an air assist is basically a must. After that comes the shot where I explained the controller box, and this part that is coming now is for the end of the video. So I hope this helped you see the differences between the 10 watt and the 10 watt plus laser, and I think we can all see that the 10 watt plus does have a lot of advantages going for it. It is a much more complete package and it is not that much more expensive. So make sure you go to the Endurance website and check the two out and get your own laser today. So here you can see the nice controller box that is included with the 10 watt plus laser. It is made out of metal and super high build quality. There's a temperature readout of the metal that the diode is in. You can see the voltage that is coming in, and here you can see the voltage and the amperage that is sent to the laser. There also is a key so you can securely turn on and off the machine and different modes. You can either feed it with a PWM signal or with an analog in signal, and that gives you just a lot more flexibility while just choosing different methods to control your laser. The laser box on the 10 watt model in comparison is quite a bit more basic and just gives you the very essentials. Now if we just quickly turn on the laser, I don't want to turn it on too long since I have disconnected the cooling to have this video be more quiet. We can see here that it gives you the voltage down here, it gives you the nice amperage, and with this selector switch here you can change the modes between the different modes that are available. Alright, so here we have the test. Down here was the 10 watt laser without an air assist. You can disregard the most bottom row. Up here is the 10 watt laser with the air assist, and over here is the 10 watt plus laser. We're going to take a look at these acrylic pieces later. So as you can see, the air assist just makes a lot cleaner finish, and it also does improve the cutting performance slightly. If I just lifted this up, you can see that without an air assist only need the 2 passes 100 millimeters a minute just drops out. I could probably push out some of the other ones as well, while on with air assist the 150 millimeters a minute with 2 passes also is just dropping out. Now you were probably able to see that the entire 2 passes row dropped out with the 10 watt plus laser, and also the single pass 100 millimeters a minute and the 150 is, well, basically dropping out as well. Now that makes it look like the 10 watt plus is just so much superior than the 10 watt, but there is a bit more to the story than meets the eye initially. Let's take a look at the back of this. Here on the back you can see all the patterns of what didn't cut quite through. Now you can disregard this here, this was just failed engraving and I reused this piece. Sorry, it's kind of distracting probably, but try to just ignore this. And you can see that here along the x-axis it is cut through with almost all of them. Now of course, like the 300 millimeters a minute one pass did not cut through, but that didn't cut through either on the 10 watt plus. But you can see like very clearly on many of them that the x-axis cut through entirely while the y-axis did not cut through at all. And I think this is just due to an issue with the diode. And all laser diodes are not perfectly rectangular or circular if you focus them perfectly. It is just due to their nature to output like a rectangular laser beam. Now, by focusing them, you can decrease the size in X of this laser beam, and you can make it flatter and flatter, and you can make it almost to a point, but no, it's not actually a point, it's a very slight line. Now, the specifications on the Endurance website is that it's about 130 micrometers long by about 60 micrometers tall. Depends a bit on what lens you're using and other variables. But this means that it is about twice as wide as it is high. Now, from experience and from testing, I know that my 10 watt laser is not 130 microns wide. If I focus it perfectly, the laser beam is significantly wider. It is closer to maybe 400 microns. And I don't know the height exactly, it's probably much closer to the 60, and that just means it's a much longer line. Now this can be that I somehow damaged it, I haven't noticed it quite as extensively in the beginning, or it could be that it's just the laser diode that is not quite as good. And what that causes if the laser beam is so much wider is that if it moves along this axis, it doesn't matter as much. The power in the spot might be less, but every single part of this longer line moves over this point, and that's why it cuts through still. It just is a little bit less power, but for longer. If it moves in the other axis though, the cut width is wider, but the laser power that a single spot gets exposed to is significantly less. And that's why on the y-axis here it is not cutting through, because it is just distributing the power over a larger surface and trying to make a wider cut. This is an inherent problem of all diode lasers, but by using good diodes and using some clever optics, you can just reduce this effect. On the 10 watt plus laser here, you can see that a lot of them dropped out, and the ones that it didn't drop out are much more uniform. But they still have this issue where one of the axes is not cut through quite as much as the other one. Now, from just looking at the spot size and by eye, the 10 watt plus is much closer to the specification. I don't have any tools to measure exactly how wide the beam diameter is, but I imagine that it is about the 2:1 ratio or something like that is specified on the website, and that's why it cuts through a lot more. Now, it does also have more power apparently than the other one, but the difference is not quite as large as you might think from which parts dropped out and which parts didn't. If you take a quick look just at the edge, it is fairly clean. Now, it is of course charred. That is just because it don't have enough power to pulverize the material quick enough to not leave a black finish, but all the ones with an air assist are fairly clean on the top and the bottom and just have like a dark brown to black edge, and that is, I think, pretty good. Now, with air assist you of course get ugly markings, and I guess more of the story is use an air assist no matter how powerful your laser is. But it is also quite nice to see the 300 millimeters a minute with 2 passes going through, and you can see that the edge on this part is significantly lighter than on, for example, the 100 millimeters a minute part, and that is just because it is moving faster. It's not giving the wood quite as much time to char. So this is probably the settings I would use when I'm doing further projects. But now let's take a look at some acrylics. Here we can see 2 tests I did. First, I did it with the air assist, and I kind of noticed that the air assist is not doing it any favors. On the engraving, it kind of almost blowed some of the kind of softened up acrylic into one direction, and there are like even some strings. So on this second test, I disabled the air assist, and the performance was actually a lot better. On the first one, only the 200 millimeters a minute with 6 passes dropped out. This is 3 millimeter acrylic, by the way, in red. Clear acrylic does not work with this wavelength. If you don't know, you need to have an infrared laser for it to work. You can cut any acrylic that is not clear, so any like dark tinted acrylic or any solid colored acrylics. On this test here, the 2 passes 100 millimeters a minute also dropped out, and this one here is basically ready to drop out as well, the 200 millimeters a minute with 4 passes. So this just shows that on acrylic, don't use an air assist. It's not necessary and actually will harm you. So I remember that on the 10 watt laser, I was only able to cut through with this setting. So cutting down 2 passes is quite a nice improvement, and the edge quality, I would say, is about the same. You can see the individual passes. It's not that beautiful of an edge, but well, you are cutting acrylic. That is already a nice improvement. What I find nice to see is that 2 passes 100 millimeters a minute also cuts through. I think this is almost the nicest setting, but you can basically choose between these 2 settings and you'll be fine. The other ones did almost cut through, like this one here with 1 pass at 50 millimeters a minute, not 500 of course, which is basically just the same power as this one. It almost cut through, but not quite. So you can see that there is an advantage to doing more passes, even if it is the same power in total.